Hi everyone, my name is S. Venkatesh. Today we're going to discuss about moments. Let's get into the topic. Generally, moments are two types, raw moments and central moments. Raw moments can be defined as the arithmetic mean of various powers of deviations take from origin. The rth raw moment is denoted by nu dash, where r will be 1, 2, 3, and so on. Then the first raw moments are given by uh, nu1 dash, and second raw moment will be given by nu2 dash, and so on. Um, Here we can see the RAM means for different data, raw data for discrete data for continuous data. The first RAM moment for the raw data will be um, some summation of d by n, and the second RAM moment for the raw data will be summation of d square by n, and so on. For the discrete data, the first RAM moment will be summation of ft by Kaplan, means total number of frequencies, and the sum of total number of frequencies, and the second raw moment for the discrete data will be some summation of fd square by Kaplan, and the second raw moment for the discrete data will be summation of fd cube by n, and the fourth raw moment for the discrete data will be summation of fd power 4 by n, and the first raw moment for the continuous data will be summation of fd by Kaplan into C, where C represents the height of the class. And the second raw moment for the continuous data will be summation of fd square by Kaplan into C square. And the third raw moment for the continuous data will be summation of fd cube by Kaplan into C cube, and so on. The next one is central moments. Central moments can be defined as the arithmetic mean of various powers of the deviation taken from the mean of the distribution. Means the central moments can be formed formed from the mean of the distributions, and the rth central moment is denoted by nu r, where R can be represented as 1, 2, 3, and so on. First, here the table will be represents the central moments for the various data sets, raw data for discrete data for continuous data. The first central moment for the raw data will be summation of x minus x bar. X bar means mean. X bar by n equals to 0. And the second central moment for the raw data will be summation of f into x minus x bar whole square by Kaplan equals to 0. And and the third central moment will be summation of x minus x bar whole cube by small n. And the fourth central moment for the raw data will be summation of x minus x bar whole power 4 by small n. And the central moment for the discrete data will be summation of f into x minus x bar by small n equals to g Kaplan equals to 0. And the second central moment for the discrete data formula will be summation of f into x minus x bar whole square by Kaplan equals to sigma square, where sigma square can be known as variance of the data, and the third central moment for the discrete data will be summation of f into x minus x bar whole cube by Kaplan. And for continuous data, the first central moment will be summation of fd dash by Kaplan into C. See, I have told before that the C will be represented at the height of the class, and the second central moment for the continuous data will be summation of fd dash square by Kaplan into C square, and the third central moment for the continuous data will be summation of fd dash whole cube fd dash cube by Kaplan into C cube, and so on. Generally, the given n observations x1, x2, xn, and so on, the rth order raw moment will be are defined as follows. Nu r dash equals to 1 by n 1 by n into summation of f into x minus a whole power r. Here a means about the point. There are the moments about the point. This is the general representation of the moments about the point. Then next one, the general representation of the moment about the origin will be summation of f x power r by Kaplan. And next, the general representation of the moment about mean will be nu r equals to 1 by n into summation of f into x minus x bar whole power r. And x bar represents the mean of the mean of the data, different type of the data. And here we can see the relation between raw moments and central moments. Where nu1 equals to 0 and nu2 equals to nu2 dash minus nu1 dash whole square. Where nu1, nu2, nu3, nu4, these are all known as central moments. Where nu1, nu2 dash, nu1 dash, nu3 dash, nu4 dash, these are known as raw moments. And nu2 equals to nu2 dash minus nu1 dash whole square. Where we can get nu1 from the formula x bar minus a, where x bar we can know x bar as a mean, and nu3 equals to nu3 dash minus 3 nu2 dash nu1 dash plus 2 nu1 dash whole cube. Sorry, 2 nu1 dash cube. Next, nu4 equals to nu4 dash minus 4 nu3 dash into nu1 dash plus 6 nu2 dash into nu1 dash whole square minus 3 into nu1 dash whole power 4. These are the formulas which can tell about the relation between the raw moments and central moments. Mm. And the next one we can see an example. Mm, From the following distribution, calculate the first one. The first four moments have the mean, and the second one is skewness based on moments, and the third one kurtosis. And here we have given the data as income will be 0 to 10, 10 to 20, 20 to 30, 30 to 40, as they given as class intervals. And x values will be, as frequencies will be, the respective values will be 1, 3, 4, and 2. And the solution will be, now we have to find the computation of moments, skewness, and kurtosis. As we have mentioned that income has given the class frequencies as 0 to 10, 10 to 20, 20 to 30, 30 to 40, and the mid values of the class intervals will be uh, 0 to 10, 0 to 10 the mid value will be 5, and 10 to 20 the mid value will be 15, and so on 25, 35, and the total number of frequencies will be 10 as mentioned Kaplan. And the next one we can see the frequency will be as I have given 1, 3, and 4, 2. And we can find the d value as the formula by m minus 15 by 10. As 15 will be set as the assumed mean as 15. And the d values will be minus 1, 0, 1, 2. And next, the fd value will be formed by, and the next one we can find the fd square, fd cube, and fd4. The summation of fd values will be 7, and summation of fd square will be 13, and so summation of fd cube will be 19, and summation of fd for 4 will be um, 37. And the next we can see first first we have to find moments about the mean. First we have to find the moments about the first we have to find the moments about the origin. From the moments about the origin we can find the moments about the moments about uh, mean, moments about the mean, which are central moments. So first we have to find moments about point origin. First moment about the origin will be summation of FD by capital N equals to into C equals to 7 by 10 into 7 by 10 into 10 equals to 7. And the next and the next moment will be summation of FD square by capital N into C square, and the value will be 13 by 10 into 10 square equals to 130. And the next and the next moment will be summation of fd cube by capital into c cube equals to 19 by 10 into 10 cube equals to 1900. And the next moment will be summation of fd power 4 by capital into c power 4 equals to 37 by 10 into 10 power 4 equals to 37,000. And the first moment about the mean means first central moment will be nu1 equals to nu1 dash minus nu, nu2 dash minus, sorry, nu1 dash minus nu1 dash equals to 7 minus 7 equals to 0. And the second moment about the mean, second central moment will be nu2 equals to nu2 dash minus nu2 dash whole square. Then the nu2 dash value will be 130, 130 minus 130, nu1 dash whole square will be 130 minus 7 square equals to 81. And the third moment about the mean will be nu3 also nu3 dash minus 3 nu2 dash nu1 dash plus 2 nu1 cube equals to nu1 dash whole cube equals to 1900 minus 3 into 130 into 7 plus 2 into 7 cube equals to minus 144. And the next fourth moment about the means fourth central moment will be nu 4 equals to nu 4 dash minus 4 nu 3 dash nu 1 dash plus 6 into nu 2 dash into nu 2 square minus 3 nu 1 nu dash 4 nu dash 4 power 4 equals to 37,000 minus 53,200 plus 38,000 into 200 38,200 minus 7,203 equals to 14,817. And we can find the second one, how to find skewness based on moments is stated by beta 1, where beta 1 equals to nu 3 whole square by nu, nu 2 whole cube, where the nu 3 value will be minus 144 and nu 2 value will be, as the nu 2 value will be 81. So minus 144 whole square by 81 whole cube equals to 0.039. And the third one, we have to find the kurtosis. Kurtosis is stated by beta 2, where beta 2 equals to nu 4 by nu 2 square and equals to nu 4 will be 14,817 and nu 2 value will be 81. So 14,817 by 81 whole square equals to 2.26. So we have mentioned that B2 value will be less than 3. So the curve is more peaked and is platycurtic. As B2 beta 2 value will be greater than 3, then the curve is um, leptocurtic, and if the beta 2 value equals to 3, then the curve is known as mesocurtic.